Okay, everyone, please read this problem and answer the question. And you can either use the equation, which I have here on the screen, or you can use the keys on your financial calculator. So I'll give you some time to work through this. Put your answer in the chat, please. All right, so let's take a look. Let's see where we are. You plan on buying some property in Florida 3 years from today. And to do this, you estimate you will need $20,000 at that time for the purchase. You would like to accumulate these funds by making equal annual deposits in your savings account, which pays 7% annually. If you make your first deposit at the end of this year, and when you would like your account to reach $20,000 when the final deposit is made, what will be the amount of your deposits? All right, so someone unmute yourself, please, and share with the class, what are we solving for? Which variable?
An ordinary annuity,
Thank you,
but
Jeff.
for it's the payment. That's what we're looking for.
Yep. So Justin correctly pointed out that this is considered an ordinary annuity. Remember, an annuity is a series of payments made at the same time over a set period of time. Okay, so it says you are making a series of payments at the end of each year, and you're going to do this for 3 years. So that's an annuity. And Justin also said it's an ordinary annuity, which means the payments occur at the end. That's very important information, because if it's not an ordinary annuity, you would need to do something different in your calculators, and you would also make a slight change to the equation. Okay, so that's very important that you know it's an ordinary annuity. And as he also said, we are looking for the payment, the PMT on your calculators. What's the 20,000? Which variable is that?
The future value.
Thank you, Damon and Peyton. Yes, that's the future value. That's the amount I want at the end. That's the amount I want in the future. So that's my future value. What's the time period?
Three years.
And it's 3, right? Because it says how much are you going to have 3 years from today? Okay. And then the interest rate is given as 7% compounded annually. So now that we've kind of deciphered through this problem, we fill in what we know in the equation. I know this equation looks kind of daunting. It's actually not bad. And again, it's only algebra. Okay, there's no calculus in this. All right, so we know that we want 20,000 in the end. Okay, so that is the future value of the annuity that we want to have. So I just plug in the 20,000 as the future value. We're solving for payment, so we don't know what the PMT amount is. So I just leave that there. The interest rate is 7% because it gives that to me in the problem. So I literally plug in 7% everywhere I see interest, INT, or I in the equation. And the time period is 3 years. Now, to do the equation, for those of you who want to do the equation, I tell people work inside out. So start with the 1 plus the 0.07. And then that's 1.07. Raise that to the 3, to the third power. So that's 1.225. Then subtract the 1. And then you divide by the interest rate of 0.07. So I subtract 1 from 1.225. I get 0.225. Divide by 7. I get 3.2149. I then basically divide each side by that so I can have payment isolated. So I take 20,000 divided by 3.2149, and the payment amount that I would need to contribute to this account at the end of every year for 3 years at a 7% interest rate is $6,221.03. Questions? Please ask any questions if you have them on how to do the equation. I'm going to show you how to put it in the calculator next, but for those who are doing the equation, if you have any questions, please let me know.
I have a question about the same problem, but if the interest was not paid annually,
Okay,
how would we calculate it with the same equation?
so when you say it's not paid annually, do you mean, for example, let's say it's paid quarterly?
Yeah, or something like
Okay.
that.
Okay, so if interest is paid quarterly, here are the adjustments we make. Quarterly means that interest will be paid 4 times a year. Right now it says it's paid annually, so it's only calculated once a year. So at the end of every year, the bank looks at what's in the account. It takes 7% times that. That's the amount of interest, and it adds that to the account. If it's quarterly, the bank is going to do it 4 times a year. It'll take 7% divided by 4. Excuse me. So everywhere I see interest in the equation, I would divide it by 4 if it's quarterly. And then remember, anytime you adjust interest, you also need to adjust your N. Excuse me. So I would multiply N, if I can get here, times 4. Let me do this because it's kind of running in each other. Okay. So this is the adjustment that you would make if it was quarterly payments. It's still 7% interest, but it's calculated quarterly. So you divide the interest by 4 and you multiply your N by 4. Everything else stays the same. So thank you for asking that question, Retta. That's a good example to show as a modification.
Thank you.
Anybody else have questions? Okay. Let's now look at how we do it in the calculator using the financial calculator keys. First of all, we need to make sure the calculator is in N mode. That should really be your default position, okay? But just make sure it's in N mode because it says these deposits are going to be made at the end of every year. So as we said before, that's an ordinary annuity. So then in your financial calculator, you input the variables you know. So you do 3 for N. Your interest rate is 7. In your financial calculator, you just type the number 7 for interest rate. Do not put 0.07 and do not put 7 with a percent sign. Just 7 by itself. You know the future value, what you want to have in the account in the future is $20,000. So you input that in the financial calculator. In this problem, present value is irrelevant. It's just 0 in your calculator. Okay. Notice when you look at the equation, there's nothing in this equation about present value. Completely irrelevant to what we're trying to find. Okay. So we're basically just going to ignore it. And then the payment amount that is what you're solving for. So you put your cursor on that line if you have a TI 8384, and you hit your alpha key and your enter key, and you will get a payment of $6,221.03. So if I deposit that amount in this account every year at the end of each year at 7% interest rate, I will have $20,000 in 3 years. Who has questions? Everybody's all good? Okay. All right, let's go ahead and let's do the next one. So read this question and put your answer in the chat. I'm going to give you guys a few more minutes. Please, please, please don't watch us do these problems. Work them yourselves. It's the equivalent of if you want to get really good at making free throws, you can watch somebody do it on TV all day long, but in order to get good at it, you actually need to take a basketball, go outside, and just practice hitting free throws. Okay, so that's why I'm doing practice problems in class. Please work them with us. Try it yourself. It'll help you, understand what you need more help with, et cetera, et cetera. Excuse me. All right, let's take a look. So first of all, what are we solving for? What is the variable that we're looking for? Someone unmute yourself and share what that variable is.
Future value.
Damien said future value. Yes. How much has Nicola accumulated in her account? So she started something 30 years ago. How much is she going to have at the end of that time? So we're looking for the future value, FV. Okay. So it's always important to know what we're looking for. Okay. It says she's going to deposit $1,000 into this account every 6 months. Okay, we call those deposits annuities. What type of an annuity is this?
Ordinary annuity.
Ordinary annuity. Thank you, Yuhang. Yes. If it doesn't say if the deposits are made at the beginning or the end of the period, you always assume they are made at the end. That's very, very important, okay? So you are going to assume, since it doesn't specify, we are going to assume she's making these deposits at the end of every 6 months, which would be an ordinary annuity. All right. Okay. The interest rate is 8%, compounded semi-annually. What adjustment do we need to make to the I?
Divide it by 2.
Divide it by 2. Thank you, Owen. So remember, we are almost like detectives when we read these questions, and we're trying to ferret out clues to decide what we need to do. So we need to take our interest rate of 8.5%. That's an annual rate. If it doesn't specify, you just assume it's annual. But it says compounded semi-annually. So that means we're going to need to divide it by I. And if we divide it by 2. If we divide our I by 2, we always multiply the N by 2. Okay, by the same number. All right, so first we're going to do the equation, then we'll do the keys in the financial calculator. Here is the equation of a future value of an annuity. That's what we're looking for. How much are we going to have at the end of 30 years if she deposits $1,000 at the end of every 6 months at an 8.5% interest rate compounded semi-annually? Okay. So I'm literally just going to plug the numbers into the equation that I know. So I know this looks like a lot of numbers, but just bear with me here. So what we're solving for is here, future value of an annuity. So I just leave that there. The payment amount is given to us. It's $1,000. That's what she's depositing. The way I tell people to think about it is you pay your car note, you pay your rent or your mortgage, you pay your utilities, you pay your cell phone bill, you pay your Netflix bill, also pay yourself. That's what she's doing here. She's taking $1,000, she's depositing it into an account every 6 months, and she is going to have that money. It's going to basically grow, and she's going to have that money available to her in 30 years. Okay, she is paying herself. There are lots of people who work for their money, including me. But the other thing I love to do is I love my money to work for me. I work for my money, but I also have my money work for me. The way you do that is you save and invest your money and allow the power of compounding to make your money work for you. Okay, so she's going to take this $1,000 that she's depositing every 6 months. She's going to make that money work for her. All right. So in the equation, we know the interest rate is 8.5%. That was given. It's compounded semi-annually. So what the bank is going to do, if this money is in a bank, it's going to say, okay, at the end of the first 6 months, so that's June 30th, we're going to see whatever amount of money is in that account. We're going to multiply it by 8.5% divided by 2. So that would be 4.25%. And that's the amount of interest that I will add to the account. Okay, so we must make this adjustment here. So everywhere I see interest in the equation, I divide it by 2. Then there's only one place we need to have the time period. That's our N. It's 30 years. So our N is 30 times 2. So we're indicating that she's actually making 60 payments. It's 30 years, but it's 2 payments a year, so it's 60 payments. So I tell students, whenever you divide your I, multiply your N by the same number. That's the only adjustment we need to make. And these are the numbers that we need to fill in our equation, and then we just work through the math. Okay, and then this is the answer that I got. I'm going to show you how to put the keys in the financial calculator in a second, but does anybody have questions on the equation or anything else related to this problem? Okay, let's look at it from a financial calculator perspective. All right, first thing, I think it was Yu Hong said that this is an ordinary annuity. The payments are occurring at the end of every 6 months. Make sure your calculator is on N mode. Okay, very first thing. Then we just fill in what we know. So I literally just walk straight down the keys on my calculator. So the very first one is N. So N is 30 years times 2, since interest is compounded semi-annually. My I is 8.5% divided by 2, since interest is compounded semi-annually. My payment is $1,000 she's paying into this account every 6 months. Present value, irrelevant. You just put 0. Don't need that. And you solve for future value. Any questions? Okay, let's do one more, and then you'll go and do your team exercise. So this is the same problem, but now we have a wrinkle. Here's the wrinkle. So read B and put your answer in the chat. I'm waiting for just a few more people to respond. Come on, folks, let's practice. All right, let's see what we got. Okay, what are we solving for in B?
Future value.
You're first solving for what her present value would have been after 15 years, and then you're trying to find the future value given that present value after 15 years.
Okay, I think you're on the right track, but what this assumes is that we're standing here. Let's see, you're trying to figure out if she took the money 15 years earlier and deposited, how much would she have in the account at the end of that time? So the 15 years is the time period, and we're looking for future value. So what's the 20,000? What variable is 20,000 represent?
Is that going to be present value?
Yeah, so you put your 20,000 as the present value. So that's what she started with when she got this inheritance check. She had a check for 20,000. She deposits it in an account. She lets the money sit in this account for 15 years. Let the money work for her, right? Instead of working for her money. At the end of 15 years, she checks to see how much is in the account. So we're looking at the future value, right? Is this an annuity?
No.
No, right? So this is just a straight up, we're making one payment in the account, letting it sit and earn interest, do its thing, and then we're going to see how much we have at the end. So there's no annuity going on this B part, okay? So I assume that you guys are probably using the financial calculator, so I put up here how to do it in the financial calculator. We still make the adjustment to I, even though there's not an annuity. Because interest is compounded semi-annually, she's going to end up with more money in the account than if interest was compounded annually. Remember we did that, I guess that was Tuesday, right? So if you have more periods of compounding, your money will grow faster. So we still need to make sure that we make that same adjustment that we did in part A. So we take the interest of 8.5%, we divide it by 2 because it's compounded semi-annually. Then we take our N, which is 15 years, and we multiply it by that same number 2. So we're basically saying she is going to receive interest every 6 months for 15 years. So that is 30 periods of interest. Payment is completely irrelevant in this problem. It's the same account, Ken, so this is a good question, and we'll see how in just a second. So we've got in this, and now we're just focusing on part B. So she deposits 20,000 today. She lets it sit there and she checks to see how much she has 15 years later. She's putting it in the exact same account. So it's still earning 8.5% interest compounded semi-annually. And the N is over 30 periods, 15 years times 2. So that 20,000 grows to $69,712.70. But the question says, what is the balance in her account, including the money that she's putting in, that $1,000 she's adding every 6 months? So you need to add it to the answer from the prior problem. Okay, and that's how you get the $332,057.44. Okay, Amir, yep. So this is one account. You see this actually is a pretty common occurrence. Let's say you're saving $100 a month in your 401k account or in an IRA. So you just have $100 a month coming out of your paycheck going into your 401k account. Hopefully everybody who has one, or if you graduate soon and you get one, please put money in the 401k account. Pay yourself, let your money work for you, okay? So people will set up a 401k account. They'll put $100 a month in it for 30 years until they retire, 30 years, even 40 years, depending on when they started. In addition, let's suppose you get a really nice bonus 10 years from now. And you say, you know what? I'm going to take $10,000 of that bonus and I'm going to add it to my 401k. I'm just going to juice that little baby up a bit. So people do that all the time. So you still have your money coming out, $100 a month for 30 years, plus adding the $10,000 in there. Okay. All right. All right. So let me see. I have one more comment here. Oh, okay. I got you, Owen. So Owen mentioned a different way that he approached the problem, and that would work. So Ken, if you look at Owen's explanation of how he did it, then if that's what you're referring to, that would work. Okay. All right. So what we're going to do now is I am going to put you back on your teams. Well, first of all, before I do that, any questions? Let me ask that. Any questions?
Yeah, I have one question. Is the test going to be open answer like these questions, or is it going to be multiple choice?
It'll probably be both.
Okay, thank you.
All right, so let me stop share here. And we're going to get ready to go on our team. So I will stop the recording.